To start the mathematical process, we need a few definitions. For consistency, A will be our transformation matrix, x bar will be our eigenvector, and the Greek letter lambda will be the eigenvalue. What does it mean that the vector only changes in magnitude and not in direction? It means that the matrix vector product gives the same value as multiplying the vector by a scalar. Or in other words, A times x equals lambda times x. As a reminder, our first step is to find the eigenvalue, the scalar lambda. This equation may seem a bit odd as we have a matrix multiplication on one side and a scalar multiplication on the other. To make more sense of this, we can make use of an identity matrix I. Notice that multiplying lambda by I does not change the equation. Let's look at our equation again and substitute lambda by lambda times the identity matrix I. So A times x equals lambda times I times x. Since now we have a matrix multiplication on both sides of the equation, we can manipulate it a bit and change the equation in such a way that's easier to solve. A minus lambda times I, all of this times the vector x equals 0. We need to find the non-trivial, or in other words, the non-zero solution for the equation. If A minus lambda times I is invertible, we can divide it on both sides and end up with x equals 0, which is not what we want. In other words, we need to find lambda such that the matrix A minus lambda I is not invertible. As I mentioned before, to thoroughly understand this theory, you will need previous knowledge of linear algebra concepts. Here is where you need to remember some theories relating to determinants. For the matrix A minus lambda I to be not invertible, its determinant has to equal 0. This equation, where the determinant of A minus lambda I equals 0, is called the characteristic equation of a matrix. When specific equations are important and are used a lot, they are sometimes given names. It makes it easier. So instead of saying the determinant of A minus lambda I equals 0, we simply say the characteristic equation.